Hi everyone, super thrilled to be your host today. My name is Nick, developer advocate at ScaleOps. Today we're going to talk about how Roku transformed their resource management with ScaleOps. So the before after picture, the actual results they've seen, and most importantly, how they actually rolled it out. I'm very pleased to be joined by Dieter today from Roku to tell us that story. Dieter, thanks for being with us today. Before we dive into the Roku environment, do you want to give us a quick intro to your role?
Yeah, sure. I have been doing cloud financial management since 2013 at companies like Google, Netflix, Intuit, and most recently Roku. I'm also a FinOps ambassador of the FinOps Foundation.
Cool, awesome.
Thanks for having me.
Yeah, I'm very pleased to have you today. So hopefully it should be a very informative session and a fun one. So awesome. And for those of you new to ScaleOps, we are a cloud resource optimization platform. Our goal is simple: improve performance, free engineering time, and also save your cloud cost as a byproduct by making sure your workloads get the resources they need exactly when they need it. We handle the heavy lifting of vertical and horizontal scaling, node auto scaling, and even GPU sharing, all based on real-time demand and your specific Kubernetes cluster context. So let's take a look at what we have in store for today. But before that, a few housekeeping components. This session is pre-recorded, but when it goes live, we'll be here to answer all your questions. So feel free to ask all the possible questions. We'll answer them live. All right, so agenda for today. We're going to start by stating the problem, why Kubernetes cluster are chronically oversized. Then we'll move into Roku before ScaleOps, what was their starting point, then the outcome and impact, what's changed. Then we're going to go a bit deeper into how it actually works and the experience. And finally, we'll conclude with lesson learned, wins, friction, and what's next for Roku. Okay, let's start with the uncomfortable truth. Somewhere between 60 and 70% of the resourcing you're paying for in Kubernetes are sitting unused. Everyone knows this, but nobody fixes it. Why is that? Well, because the cost of under-provisioning is immediate. You're risking OM kills, latency spike, on-call teams being waken up. But on the opposite, the cost of over-provisioning, well, it's just a bigger bill. Nobody is getting fired for a bigger bill, so engineers pad their requests and they pad them generously. And why the manual approach doesn't work? Well, it works when actually you have about 10 services. You check the metrics, make a guess, update your YAML file, your YAML manifest. But at scale, you've got hundreds of services, also traffic patterns that change constantly as you deploy new application or new versions of your application, and engineers who leave and take the knowledge with them. Nobody's going back to revisit sizing after the initial deploy, generally speaking, and it becomes a set it and forget by default. Also, why native tools don't solve it? Well, first, let's talk about VPA. 5 reasons it doesn't work at scale. The first one is that VPA has to restart pause in order to resize, meaning that it's disruptive regardless of your production constraints. And most of the time, that's a non-starter for many people. The second one is the global histogram decay in VPA. Just looking at historical data is not enough. It can hide spike and recent demand changes. That can lead to a big tax on performance. The third one is that VPA, as a result of that, is often run in recommendation mode off. So as a result, teams often set VPA to off and simply never look at the numbers back. And the last one, also very critical, is that VPA doesn't validate its recommendation against cluster context. So you can have recommendations that don't fit your nodes, for example, or bad recommendation applied again and again, leading to things like OM kill loops, and more disruption. So basically destroying the purpose of VPA. And also when you combine it with HPA, those two is an anti-pattern. They fight over the same metrics. VPA changes the request, which makes which makes HPA break, and you get scaling thrashing. So essentially, native tools exist, they just don't work together, and that can definitely make impact on your SLOs. But here's the thing, when adopting a cloud native resource management solution, the real blocker isn't technical, it's trust. Engineers are afraid. What if you experience OMs in prod? What if latency spikes happen during a traffic peak? Who's responsible when something breaks? The downside of being wrong about resource sizing is sort of career impacting. But the upside of being right is just a smaller cloud bill that sometimes nobody thanks you for. So everyone pads, because better safe than sorry is the rational choice to make. This is where scale-ups come in. We build the product around one specific insight. Safety unlocks automation. If you can make engineers trust that the system won't break production, then they'll let it optimize. The guardrails aren't a feature, they're at the foundation of the product. So enough from me though, let's hear how this actually played out at scale. So Dieter, let's talk about where Roku was before scale-ups entered the picture. And let's set the theme. So before scale-ups, how were workloads typically sized across your organization?
So at Roku, each engineering team is empowered to make their own decisions. And I've seen the same pattern across other organizations as well, right? Essentially, you build verticals, and within the verticals, they are allowed to make decisions that are best for their business outcome. So each engineering team manually sized those workloads, and they were sized for the worst case production situation, right? Highest peak traffic, those kind of things. And essentially, over time, there were little changes made.
Okay, so was there like a standard policy, or was each team doing their own thing on their, on their side?
No, each team was responsible for, or is responsible for their own workloads. The individual teams may have policies, might as well, right? Okay. But there was no sort of like an organization-wide Kubernetes sizing policy. And as far as I know, that still doesn't exist.
Okay. And then how often were those teams actually revisiting those numbers?
Not very often, maybe once or twice a year, if that, on an as-needed basis.
Needed. So what would, for example, trigger a particular change in this configuration?
If the team is aware that the load on the workload would change, right? Let's say there's more viewers or more TV channels or something of that nature, right? Where the workload has to process more, and the team is trying to estimate what that more looks like, or if there was some type of incident like a production outage.
Okay, no, that makes sense. And then, so what was the biggest reason your team stayed conservative in production? What were you most worried would go wrong?
Well, we don't want to be the responsible individual that is causing outages or incidents, and especially waking up engineers at night. Right? So we don't want to be the cause of that. We are much happier if someone else is the cause and we can help them, but we don't want to cause these types of incidents.
Yeah, I see. Like good technology is invisible technology, right? Okay. So now let's maybe talk about what you tried before. So what sort of optimization existed before scale-ups? What did you try? Any homegrown scripts? Anything? You mentioned manual and things like on as needed basis. And we're using anything else at all?
Yeah. So Roku's journey into Kubernetes started maybe like 5 years ago, something like this, right? I work in the Cloud Center of Excellence. So there's a central technology and infrastructure team that is sort of responsible for technologies that are shared across the Roku organization. So multiple engineering teams take advantage of that, right? And so Kubernetes is one of those technologies that the idea was to have a boilerplate install that an engineer could take just the CloudFormation or the Terraform script, right, and get their Kubernetes cluster set up with everything included. And so part of that journey, we actually hired a director because the existing team realized that they needed someone with deep Kubernetes background to lead that journey, right? And also make decisions along that roadmap, right? Or help facilitate decisions. And so part of that, the director came and they used a horizontal pod autoscaler, and that is that HPA, right, that we mentioned before. But we haven't done anything for the VPA itself, right, for a vertical pod autoscaler. And so while the HPA worked reasonably well, I kind of pushed for, hey, there are other technologies available, right, that do vertical pod autoscaling optimization. And so we should try that out. So as part of that roadmap, at some point, we decided, hey, we need to do a proof of concept to see what this is all about.
Yeah. Okay. Now that makes sense. So horizontal scaling automated, but vertical was completely manual. Is that right?
Correct.
Okay. So let's talk about how you actually roll this out. So you said you had first your HPA, and now you want to go into more like, so right sizing. Did you start with dev, go straight to prod, cluster by cluster? What did a safe rollout look like for Roku?
So at first, we actually started with a proof of concept because we didn't know the technology at all. And we knew that we had a horizontal pod autoscaler or horizontal optimizer. And so we didn't know how these two would interact with each other, right? We didn't want them to step over each other's toes, right? So we conducted the proof of concept. That after that was successful, then we decided to still be conservative because, again, we didn't want to be the cause of engineers waking up at night, right? So we started with like dev, test, staging, QA, and we slowly, gradually moved into the production environment.
Okay, now that makes sense. I mean, that's the safer side of things, but at least, yeah, as I said, invisible technology, the less possible impact, but still like reaping the benefits of the technology. And then, so I imagine, I mean, Roku is big, so who had to sign off before you could expand?
So we did the proof of concept first, right? And that was a free trial and limited in time. So we needed finance approval, right? We needed budget approval. That was relatively easy because we could justify the expense through the savings. So at my current organization, that is an easy conversation to have with finance. It is much harder if you need to buy a product that is an add-on, right? And it's additional cost while the user base stays the same or grows slightly over time. But this was essentially funded through the savings itself. And then because we have that central technology and infrastructure team, right, that is a part of the Cloud Center of Excellence, we were able to provide that boilerplate Kubernetes install to all of Roku's engineers that needed a Kubernetes cluster.
Yeah, no, yeah. That makes a lot of sense. And I guess in terms of in terms of scale, how many clusters does that represent, and how out of those clusters, how many did you start to automate with scale-ups, or first install scale-ups on all those clusters, or was more like progressive?
That is actually an interesting question. So you mentioned before that we are using Prometheus, Grafana, Loki, and those kind of things that are part of that standard Kubernetes install that every engineer can choose. At Roku, we have over 110 clusters. So that is sort of the target area, right? And we have internally, so Kubernetes has version numbers, right?
Yeah.
Everyone is aware there's like different Kubernetes versions. And so internally we have, for that boilerplate install, we also have version numbers, right? So starting at a specific version number, the VPA or the HPA becomes automatically available. So if you have an existing cluster that you upgrade to a newer version number, you then automatically get the benefit of that HPA and VPA. Now, there are some clusters that are maybe in maintenance mode, right? We don't want to touch them. There's really no engineers assigned to them. So they are not getting upgraded and they are not able to see that benefit.
Yeah. Okay. Now that makes a lot of sense to do it this way, and having all those profiles. And I mean, I guess it's easier when you scale to have all those processes in place. Okay, so now let's talk a bit more about the aha moment. So once scale-up started profiling your workloads. So you install first the POC. I don't know, maybe it was during the POC or you first, I think, running out a solution into your own environment. Still better than doing in a POC when you may have like patterns that surprised you about where the waste actually was.
Yeah, I mean, absolutely. During the proof of concept, we realized that we needed that we were able to save somewhere between 15 and 30% by using a vertical pod autoscaler or a vertical optimizer. Right? And the interesting observation here was that this was in addition to the savings of the horizontal pod optimizer, right?
Okay, so vertical and horizontal compounding, so not like either
compounding. Or. No, okay. Absolutely, right, and that was the surprise. Honestly, at the beginning, I was really concerned that the two optimizers would start fighting with each other, right?
Yeah,
in computer science, this is called a race condition, and race conditions are really bad, right? They can spiral out of control quickly. So that was my main concern, that these two products would fight with each other, and we would have terrible results. So one of the aha moments was like, no, the products actually work really well with each other. That was surprising to me personally, maybe not to the engineers that worked on that, but I was really happy to see that. And I was also surprised that, the HPA saves like 15 to 30%, and the VPA saves an additional on top of that 15 to 30%, so that you have 30 to 60% on average savings based on the workload, how much optimized your workload was before these products started engaging, those kind of things.
Yeah, just like, this saving are basically paying for the solution itself. Like the ROI is almost instantaneous when you see that. So everyone is happy, and the person also owning the wallet must be happy as well, I guess.
Exactly.
So then now in terms of, engineering, what's changed day to day for, engineering once this was running, really?
So not really much changed, if anything changed for the engineers, because they still have their manifests, they still have the regular way they configure their pods. And this product then goes and does the optimization behind the scenes, right? So if the engineer they can optimize, right? They have the freedom to do so, but they can just throw things over the fence, and then this product will automatically optimize that and take care of things.
No, that's great. That's great. So basically what you're saying is it was invisible to the teams that were consuming it. And this is what you wanted from day one. You say like, no one get paged at 3 a.m. in the morning, like not a lot of impact from the technology, but still reaping, the benefit from it.
Absolutely. Yeah, you're absolutely correct. Right. And that was also a benefit, right? Like, for example, we turned this on in dev, test, QA, and staging environments. I mean, we did tell people, but not in a very synchronous way. Like, we sent out an email and said like, hey, this is going to happen starting this date, right? If they didn't read the email, then they may not even have been aware of that. And that worked very well.
Oh, that's cool. And so before you mention, your boilerplate Kubernetes install that comes with observability, Prometheus, Loki, Grafana. So now what you're saying is that it comes with scale-ups pre-install as part of this package as well?
Absolutely. Starting at a certain version number, right? You get scale-ups automatically with that install.
Yeah, that's great.
And if you are upgrading to a newer version number that includes the scale-ups package, it comes, the upgrade will automatically include that.
Okay, no, that's great. Yeah, I understand. No, that's fantastic. So now, this is where we summarize the number. We'll go through them a little bit. So if you can expand a little bit on the impact scale-ups had in your environment. So first we can start with the, once you've enabled automation, and then we'll go down by adding different features, what you've seen so far, and, what's your kind of prediction are for the rest.
Yeah, so scale-ups is not active on every cluster. I explained it is dependent on your version number that you're running of that internal Kubernetes boilerplate install, right? So we have about 20% of our Kubernetes workloads are actively running scale-ups. And
so automation, when you say it's fully automated, right?
It's fully automated.
20%.
Yeah, okay. Exactly. There's no manual intervention or configuration required. You have an existing Kubernetes cluster, you upgrade it to a newer version, you get scale-ups automatically with that, and it just works, right? And so about 20% of our clusters are currently, these numbers are actually a little bit older. The actuals are a little bit higher now. We are gradually rolling out more and more, right? And we do see a vCPU reduction of 32%.
Well, that's amazing. So 32% already, but only a 20% automation organization, right? Wide, right?
Correct. Mm-hmm.
Okay, that's very nice. And now, if you add the layer in node optimization, did you have any any opinion on that, or how did you make prediction?
Yeah. So with node optimization, so first of all, we anticipate that the vCPU reduction with a full rollout will increase to 68%, right? And then if we add node optimization to that, we are anticipating a slight increase to 72%. And then there is something called replica optimization. If we add that, we get another 10% on top of it.
Well, that's amazing. So so basically what you're saying, you're 32% today with a clear path to 70% plus, and this is with a cautious, safety-first rollout.
Exactly.
Okay, cool. So now for people to understand, I want to go a bit over how you make those savings, because of course, you are touching the pods. At the moment, we didn't talk about the nodes. So those are the numbers, but I want to double click on something here, right? Because right sizing alone doesn't get you to 70% saving. You can make pods smaller all day long, but if they're still scattered across the same number of nodes, your cloud bill doesn't change. The nodes are still running. So let's get into the mechanics of how this actually translates the real cost reduction. So right sizing here is the headline, but here what actually happens day zero. So the Kubernetes scheduler, as we know, is stateless. There's no native way to say, hey, these pods would fit better over there, move them around. It's your cluster autoscaler that tries to consolidate. But it's actually blocked until you restart the pods and tell them where to go. And ScaleOps fixes this using native Kubernetes primitive. And this is an important point because we don't change the scheduler itself. And the result is that pods naturally cluster together. Nodes actually become empty. And now your native cluster autoscaler or Carpenter can do what they're designed to do, which is remove those empty nodes. And that's the day zero value, actual consolidation that wasn't possible before. So Dieter, did you see this consolidation effect play, like early nodes actually emptying and getting removed as you deploy, you can mention, I don't know, maybe multiple cluster. What was your experience? How much in teams had to wait before actually seeing nodes getting removed?
Yeah, and we already saw that during the proof of concept, right? And that is something that was extensively tested because this is where your savings happen, right?
Yeah.
That you have smaller pods on the same number of nodes doesn't save you anything yet. So I appreciate this infographic here, right? And then we tested actually not just one vendor, we tested multiple vendors, right?
Yeah,
And
of
one
course.
thing that we noticed with scale ops is that the ability to free up or give back virtual machines to the cloud provider was extremely fast. And
Yeah.
that is important, right? Because we tested different solutions, and some solutions, you basically pay for for every minute that you use a virtual machine, right? Let's say you have
Yeah.
something that is, 4 cores, 8 GB of memory or something like that, right? It has an hourly cost, but it gets prorated for every minute that you're using it, right? So it makes a difference if whatever you're using to free up these worker nodes is it takes 50 or 55 minutes to free up the worker node
Oh, yeah, that's a lot. Yeah.
versus 2 or 3 minutes. So you're
Yeah.
saving an hour cost, right? Almost an hour cost every time this worker node is freed up fast enough. So that was an important thing that we tested.
Yeah, and there's, I guess, a lot of moving parts to take a look at. There's all the unevictable, and how you can influence the placement of those pods, and all that can take time. And I would say, how important was the fact that we keep using, because some people are quite sensitive to the fact that you want to continue to use Kubernetes native, primitives, and automate on top of that, as opposed of, gradually replacing some stacks inside Kubernetes.
Yeah, I mean, again, it goes back to what the engineers prefer, right, and how much training they have. So at the moment, we don't really have a mandate to use any like scale-up specific manifests, right? If the engineers are eager and interested, they have the freedom to go and use these. But there is no organization-wide mandate to have them switch, right? They can basically continue doing their work as they are used to. And then if they want to upgrade, yes, they have the ability to use scale-up specific functionality.
Yeah. Okay. And I guess also, where I'm going with this is, depending on the solution, it's easier, if something goes wrong, and hopefully nothing will go wrong, or if you have to monitor, or it's easier if you know already Kubernetes and the solution just works with Kubernetes, then you don't have to build an extra layer of knowledge to learn about, the system and troubleshoot that. And I guess in terms of onboarding, make things a little bit faster as well.
Exactly. We want to make it as lightweight possible, right? As light of a lift possible for the engineers. I mean, if they are operating on Kubernetes, hopefully they know Kubernetes a little bit. But there's always a little bit of a difference between, some lead engineer will know a lot, right? And they may be interested in further optimizations. So we are happy to have additional automated systems that they can, fall back on and put into their knowledge stack.
Yeah. Okay. I see. Cool. So now let's go a bit more deeper onto the, how does the day zero look like? So you install scale-ups, then what happens? I'm just, before asking you the question, Dieter, I want people to understand, and also so you can get we can know about your experience. So first, scale-ups, when you install it, it runs in read-only mode. So I didn't mention, but that's maybe a difference with other solution. Scale-ups is self-hosted. We also have like a SaaS, ability, a cloud ability where you can consume scale-ups. But by default, it's self-hosted. And when you install the product via Helm, it runs in read-only mode. Which meaning that it's observing your workloads and generating optimization opportunity as soon as you install it, right? It starts giving you those opportunities. But it's not touching anything yet. This is where you see what it would do. So you can review the data, then flip the switch on automation. And that's when consolidation starts happening. This is where we mentioned we start with the pods, so reducing or sometimes increasing the size of the pod depending on the demand, and then combining, bin packing, grouping those, clustering those pods together, and basically given cluster autoscaler or Carpenter the ability to remove the nodes because now they are empty. So Dieter, what did that day zero experience look like for you? How long did you run in observation mode before enabling automation, essentially?
I think for the proof of concept, we actually ran a considerable amount in read-only or observe-only mode, right?
Yeah,
I think
as a proof of concept, yeah, you wanted to see. Yeah, see, nice.
I think something like 14 days, right? Just to see what the recommendations would look like, right? And learn how the system would look, how the system would work, and what kind of changes the system would apply. One thing that the engineers that were responsible for the proof of concept really liked is the ease of installation, right? It is sort of a drop in and forget solution, right? And it's literally designed to not cause any friction or production outages.
No, yeah, that's cool. And so, did anything surprise you, like in terms of the optimization recommendation? Like, were they aggressive, conservative at first? What do you think?
No, I mean the depending on how optimized the individual containers or they call pods, right, already were. We did see 15 to 30% optimizations. Specifically during the proof of concept, that specific workload had a 20% optimization lift, right? So that was already sufficient then to make a mini business case to the finance department to justify the budget for this product.
Yeah, if you can get, I mean, actually what you were mentioning before is that you get actually more than that, especially when combining VPA, I mean, right sizing, which is our, replacement for VPA and HPA together, right? So essentially you got more than what you were expecting, which is always good to have, I guess.
Yeah.
Okay, cool. So now if we can just summarize the before from after. So let's talk about that day to day again. So if a new service is launched today, so first, what did the resource workflow look like before? So you mentioned a couple of things about manual things. Yeah. Manual. So everything was manual.
Yeah, exactly.
So now what's the same workflow look like with scale up in place? So you mentioned no change. And also, do you use any sort of, so you said no scale-ups manifest for the moment, but how do you deploy, like using GitOps? And are you considering automating even a bit more by also combining scale-ups into your GitOps pipeline?
Yeah, we are exploring that right now. I mean, essentially, nothing really changed for the engineers, like we mentioned before, which is really good. The engineers can sort of upskill if they want to use a scale-ups manifest, right? That is specifically for scale-ups. Scale-ups again is fully automated. It does not interfere with anything. It does not cause any outages. And one thing that we really like, because I did mention that we tried out other vendor products as well, and the scale-ups reacts very well to out-of-memory kills, right? You mentioned that before. So that is when the VPA, so the vertical port autoscaler or the vertical optimizer, reduces the resources of a container, right? So let's say the container asks for 4 cores and 8 gigabytes, but it really only needs 2 cores and 4 gigabytes, right? The VPA automatically reduces that, right? Because a container may change what it is doing during the 24 hours of a day, right? So maybe during business hours, it is doing like online processing, right? And then after business hours, it switches into a batch processing mode where it needs more cores and more memory, right? Yeah. So let's say the VPA gave it two cores and 4 gigabytes, but it really needed more. And you get the out-of-memory kill loops, right? That the VPA keeps giving 2 cores, 4 gigabytes, 2 cores, 4 gigabytes. And the process fails and fails and fails, right? And here ScaleOps is able to adapt right away, right? Very fast.
No, that's true. And actually, this is, I mean, two things. Part of what I've mentioned before, like with other, solution or VPA, you have this historical data that is, still counting a lot in today. So basically, it's like you're driving, but looking at the rearview mirror. And definitely scale ups. There's a couple of things I can mention. What you're talking about. There's two things. The one is self-healing capabilities, and the second one is our fast reaction. So this is exactly what you're saying. If workload experience sustained spikes, then we can change things around and moving from more like historical data analysis to something that is much more real time, avoiding this, errors and bad recommendation happening in a loop. And I think, you mentioned I'm very happy you mentioned that, because I see, I'm doing a lot of, demos and showing things around. And I think personally, it's very, very impressive to see that in action. The speed to which we can react to problems. So not only right sizing, but the ability to almost react, in real time to correct things. Because I think, I don't know your opinion, but costs is great to make your business case. But the value at this stage is also performance stability and making sure engineering is not a hurdle for them to work with that solution, right?
Exactly. If a production outage itself, depending on how widespread it is very expensive, right? It's tens of thousands, hundreds of thousands. If it is the cloud provider has issues, right, that happens occasionally, then it's millions of dollars. And the same is when you have security incidents, right? So it's not worth the dollars. Rather, you want to be safe and secure. And this is one of those products that is literally designed to not cause outages.
Yeah, exactly. I'm really happy with that. Okay, cool. So let's close this up and wrap this up with some lessons learned if you want. So looking back, what worked well, what was harder than expected, and what's next? So first, what worked really well for you?
So the product was really easy to install and set up, but we had to justify, or we had to calculate the savings. And that is something that we're not really, that doesn't really happen in regular day-to-day operations, right? You run your workload and it has a cost X, right? But now we had to set something up and say like, okay, here's the optimized workload and that has a cost Y. What would the unoptimized workload have costed, right? And so we needed to set up this kind of comparison testing, which is something that was part of the proof of concept, but is not part of day-to-day operations.
Yeah, I see. Yeah, not something that you were used to do, guys. Okay, I see. So what you're saying is the product was ready before you were, because like it installed in 5 minutes, starts optimizing, and then you took more to get prepared to what unoptimized look like. So more effort to unoptimize rather than optimize. Okay, cool. So and then what's next for Roku now?
So we are now looking probably Q1, Q2. We are going to do more proof of concept that look at alternatives for a horizontal pod autoscaler or horizontal optimizer.
Yeah, basically our sort of, it's called replica optimization with scale-ups. It's great. So last question, I would say. So if you had to tell another platform team one thing about your journey, what would it be? Like any advice? So we're talking about scale-ups here, but also more into like people who want to automate resource management, which can be quite a big leap, right?
There's something that you mentioned at the very beginning that was, I want to describe it as faint, right? But I would want to bolster it a little bit, and that is human psychology. Yeah. If I don't do anything, I get to keep my job, and the company gets to spend the same amount of dollars that we have been spending in the past, right? If I do something and it doesn't work, worst case scenario, I can lose my job, right? Yeah. And I think you mentioned that at the very beginning, and that human psychology is something that is very important. Here, I think it is important to understand that these products were designed with that in mind. And I mentioned it before, drop in and forget, designed to not cause production outages or any types of incidents. And so the very first step that I would recommend is to use the product in observation only mode, in read only mode, right? Because it does not need anything. It doesn't even have a cost. You get that for free, right?
Yeah.
And see what the product does and use that, the projected savings, as a mini business case to the engineers, to finance, to your CFO, to you, a CTO, or those kind of people, right, to communicate that. Because I think once you put that in front of a CFO and say like, hey, we can save 32% of cost on everything that is running in Kubernetes, that is a very powerful argument. And that is something that the CFO, for the most part, cannot ignore, right?
Yeah.
Once you make that business case, they can't say like, forget about it, I'm not interested, right? They have to act on it.
Yeah. No, I totally agree with you. That's one of the aspects that is really non-negotiable for me. Like, this trust has to be there because, you don't want to do this, career impacting move just because you think the product is cool, right? It has to be production ready at scale. Resource management is something that touch, the whole cluster, and that can potentially, if it goes bad, like, I remember at the beginning of Ansible and those automation technology, the problem was automating is great, but when you automate something bad at scale, you just scale very badly, right? So that can cause a lot of issues. Yeah, definitely. Okay, cool. So before closing on my side, it's already displayed there. If I had, a couple of key takeaways to give people, if you have to remember a couple of things. So first, as Dieter mentioned, safety for resource management skills, trust is the bottleneck, and guardrails unlock automation to have, all those safety in place. Two, prod and non-prod need different strategy. So on the one side, prod must get reliability guardrails. And for non-prod, of course, we mentioned proof of concept, but if you also have, dev test environment, you can be much more aggressive there and even save more, right? Three, VPA and HPA savings can compound, but when done properly. Remember, native VPA plus HPA, they don't work together. It's an anti-pattern, for the reason we mentioned at the beginning, the death loop. So, but Dieter said 15 to 30% each stacked, and that's pretty much transformative, right? That pays for the solution. And four, last but not least, resource management. It's a systems problem. It's not a per service tuning or, annual reviews. It's continuous, automated. It must be safe above all. All right. I think that's it for me. So Dieter, do you want to add anything?
No, thanks for having me. I think it is important that the word gets out that these types of products exist, right? And again, we need to overcome that human psychology element, right? Of people just try it out and test it and see how it goes.
Yeah, no, I agree with you. So I want to thank you very much for coming today. I want to thank Roku. We're very happy to have you as a customer, and we're even happier that you get all those benefits. And I hope this session will be useful to people that can learn things. And that's about it. Take care, everyone, and I hope to see you soon. Bye-bye.
Thank you so much. Take care. Bye.